I've done a lot of presentations before. It's my first meetup, but I definitely feel welcomed, and I appreciate that from everybody. A little bit about where the Alexa passion kind of came from. My wife and I bought a home about a year and a half ago. We wanted to do some home automation. I'm a geek, sounded like a cool thing. So we kind of did the whole, lights and everything that you normally do. I'm very passionate about Internet of Things and 3D printing and just technology in general. And the Internet of Things group decided to do a hackathon. Ben kind of brought that to us. Dan kind of championed it. And then Dan tricked me into doing this Alexa stuff. And I'll be honest with you, it wasn't what I thought it was going to be. But it really kind of, I kind of found a passion for it. And so this is kind of what we came out of it. I wanted to abstract away, kind of the home automation layers from actually being able to produce items. And so it's been kind of a struggle to learn both how to work well with Amazon, who honestly can be a little bit of a pain, and we'll see kind of how their acceptance policies kind of can cause you a lot of process issues. I'm actually having to rewrite some stuff because of some of their policy. And it's not a big deal, but it's good to know from the get-go so that when you go to release an application, you'll know. I'll start with home automation skills. There's a couple different kinds of skills for Amazon Alexa. There's custom skills, which I think are the most common to kind of play around with. You create an utterance, and Dan's built some of those. There's the home automation. The home automation is a very standard format. It's like, Alexa, turn chair light on.
Okay.
Very simple. Very standard structured utterances that control items. And so what we're going to talk about tonight is home automation skills. This is an extremely well defined interface. It's all JSON. It all works on Lambda skills. And I think once you start to look at it, you'll go, okay, this is very simple. But then you look at kind of what's required to do it, and it can get a little overwhelming. So we'll go through all that. Unlike us custom skills, the automated skills, like I said, have a standard command structure. Normally you would control like lights or outlets, locks, my front door lock. Come on in. My front door lock is Alexa automated. I can lock it at night. Thermostats like the Nest obviously are controlled through the same interface. A quick note, you cannot unlock something with an Amazon Alexa app. It will not do it for security reasons. There's version 3 just released a couple months ago. It adds multimedia controls, including channels, volumes, media, and input controls. This is very commonly used on Logitech's Harmony Hub, which we've kind of played around with in one of our projects. And is very impressive, is a very big pain in the patootie to set up. So I will tell you, if you get one, they do work well once you get them set up. A couple examples of things that we do in our house. Alexa, fireplace off. Alexa, make my living room blue.
Okay.
We're going to have a lot of that tonight. Alexa, lock front door.
Locking. Hang on.
This is actually locking the front door of my house.
We lock the front door.
There you go. And obviously the temperature as well. What is required to build a home automation skill? Amazon is not without its need for wanting to make money.
Is she locked out of the house?
I think she knows that. Maybe I should tell her it was me. But
Don't turn the fireplace
on. Amazon Home Automation, in fact, the entire Alexa suite of controls is all done through either the Elastic Beanstalk or through AWS Lambdas. What that means is, in order to get it to work, you're going to pay Amazon to use their infrastructure. Now, one of the cool things is, if you look for it, there's some incentives out there right now. When I released my skill, I got a $100 AWS credit. I get a monthly credit for any AWS usage for my skill. I got an Amazon Dot, and my wife got this lovely pair of socks. So you're going to need a Lambda, which means you're going to write it in Python, Node.js, C# or Java. I do not recommend C#. It takes way too long to operate. An OAuth user access management system supporting access tokens, which is how you tie your Amazon Echo over to whatever account that you have. You need to control something, and you need a cloud-based transport layer to bridge the Lambda with the something. What I mean by that is something in your home doesn't have a direct address from an AWS Lambda normally, unless you've got some static IPs and want to do some port forwarding. So there needs to be a cloud component. Your device that you're controlling needs to call into your cloud, and your Lambda needs to talk through that cloud, and so that you have this transport layer in place. MQTT is by far the most popular transport layer there is when it comes to IoT. Microsoft's IoT Hub, Azure's IoT Hub, and then also the IoT Hub from Amazon all support MQTT. All functions and communications are done in JSON. So if you don't like JSON, I'm sorry. It is what it is. The OAuth access token requirement, it's very simple. You've got to be able to pair my Amazon Echo with my Lutron lighting control system that has its own cloud component. In order for me to control mine, I've got to load the application, load the Alexa skill, and then I've got to give it the username and password to the cloud component that controls my Lutron hub, that controls my lighting. If I wanted to control my mom's, I would just put my mom's information in instead. So you have to be able to pair that cloud component account with the customer. And that's where this comes in play. There's a lot of people that are a little perturbed that an access token is used. One of the problems with access tokens is that they can't expire. So if you're going to build one for somebody, you need to make sure that the expiry is very long in the future. Some people are talking about a 10 or 20-year expiration on an access token, and then all the security people in the room go, oh my gosh. You can build your own OAuth system. You can use freely available alternatives. Login with Amazon is actually a very, very good one to use, especially if you're playing around with your own skill. you can use a login with Amazon account to fulfill the requirements to get your skill up and running without the need for someone else's system. So basically, you just create a login with Amazon account, you use the keys and information in your setup, and away you go. And there's really not a need to kind of build your own thing, especially if you're just going to do a one-off implementation for yourself. For our example today, we're going to be using the OAuth that's built into the Particle IO cloud. There's a fair amount of other providers out there that provide cloud-type services that also have an OAuth layer built in that you can connect through. So that may be something that you want to look at when you're looking to build something. Certification. This is where I've run into a lot of problems. The first time I went to certify my skill, I got told basically that I needed to add the username and password to link the account. Makes sense. So I did that, came back, and now they didn't like my terms and conditions page. Came back. Now there was another problem. I'm trying to rebrand everything into a single solid brand, and I'm having some issues that the terms and conditions page, I sent it to a GitHub page, and GitHub forwards it on, and Alexa doesn't like that. So there's no redirects allowed. So it's got to be a page that doesn't do any redirects. I think it was a simple 302 redirect, but it didn't. It doesn't like that. I used the word echo in my skill name, and Amazon doesn't allow that. Imagine that, right? So echo, photon, bridge. Very descriptive, very clean, very simple. Not allowed. Now I'm probably going to call it the Particle IO home automation bridge, but I need to get with Particle to make sure that it's okay before I rebrand everything, rewrite all of my documentation, source code, rename the class, and everything else. And then the skills detail, they did not like my description, which basically was go buy a Photon, go to the GitHub page, here's the example code, and go for it, right? This is how you do it. They didn't like that. There's another guy who's got a skill out there that does a subset of what this does. I'm basically going to go steal his stuff. See if that'll pass. There's a couple of, when we talk about how the infrastructure works, there's a couple of very basic concepts. The first one is discovery. So if I say, Alexa, discover devices. Alexa, discover devices.
Starting discovery. This will take up to 20 seconds. If you haven't already, please enable the smart home skill for your smart device from the Alexa app.
So what Alexa's doing is it's going around and it's hitting every one of the Alexa skills that are attached to my account. It's sending a simple JSON that says discover.
I found 52 smart home devices.
There you go.
If your Philips bulbs were not discovered, please press the button on the bridge and rerun discovery.
And so now it's discovered all devices. That would be the ones in my home. That would be the ones here tonight that are powered up. And so that discovery mode returns back to, it goes out and it says, what do you have? A Lambda is sent a discovery request. It includes that access token that we talked about, which is how your cloud will determine who you are. The Lambda retrieves, in this instance, a list of all physical devices from the Particle IO cloud. The Lambda then checks all the physical devices to see which home automation devices are on them, because my implementation allows me to implement multiple Alexa home automation devices on one chip.
Starting discovery. This will take up to 20 seconds. If you haven't already.
So one of the nice things about that is you can see
Alexa app.
I've got a light and a fan connected to the same particle up here. And so you can control multiple devices with it. The other thing is if you want to control the same device but in different ways, there's a gentleman at work that has
Discovery is complete.
an implementation where he can take his colored lights and he can make them police lights. So his is police lights on or kitchen lights on, right? So either one turns the kitchen lights on, but differently. The Lambda then returns a complete list of the home automation devices and their capabilities of all the physical devices. This basically says, hey, this is the name of the device. This is the device's unique ID. This is the capabilities, whether it can turn on or off, handle a percent, increase, decrease, whether it's a lock, whether it's a temperature controllable device. There's color. There's even color temperature for light bulb colors temperature. It's supported in the class, but I never use it. It's for like doing like warm white, cool white type bulb control systems. I get it, but I have no need for it.
Do they have water sensor devices?
Do they have what?
Water sensor devices?
Water sensor.
Water sensor devices. No. So this is all controllable devices. One of the things about Alexa, which is which is going to need to change over the next few years, is that Alexa is a device that you initiate all communication. You initiate all interaction. So unless you're setting an alarm, right, or a timer, Alexa will not come back and tell you anything.
Sorry, I'm not sure.
There are some new capabilities for voice calls that you may be able to hijack, but I'm not quite sure if anyone's managed to hijack being able to call into an Echo, because it normally has to be initiated from one device to another. But they're working on it. I know that like the new Echo Show, which has a 7-inch LCD on it, that actually, you can tell it, look at my Ring camera, and it'll show you like your front door Ring camera. But it won't tell you when there's motion. So it won't tell you when the phone when it rings, which is kind of, I mean, it doesn't really work.
Sorry, I have the security cameras. I wanted to buy an Echo Show, but when I read about it, it turned out that the screen is really crappy pixels. So it's not really good.
I don't know. I have two showing up this weekend, so I'll know that. Right. So we've started.
Quality screen.
Yeah, we've started some Alexa stuff at the office. So I wanted a couple shows. More of an excuse to buy them than anything else. This is the flow for device usage. This is for when we want to turn on a fan. So remember when I said we had the ability to describe the devices when we brought the information back in discovery mode? There is an option to give a key value pair list of items for every device. So you can send back your own information however you want. So one of the things that I send back is the unique device ID that Photon uses to identify the chip itself and the index of the device on the chip. And so those are stored in the key value pair. To turn on that fan, Amazon's going to call the Lambda with the access token and the unique home automation device identifier. The Lambda is going to call the Particle I/O cloud, sending the command. The I/O cloud is going to contact the physical device, sending the command and returning any requested information, like temperature or whether something is locked. The I/O cloud returns the information to the Lambda. and the Lambda returns the information to the ecosystem. The ecosystem is either going to respond with an OK or provide the requested information like lock state or temperature. Does this all make sense? It's not really that difficult, other than the methodologies used and the requirements of the things that you need to do it. Building your own cloud layer is a little intense for some people. Couple downfalls of a Lambda-based system. You're locked into paying Amazon for every customer and every one of their devices. So if I'm Lutron, I better make sure that I price my devices to pay for the next 5 or 10 years of their Lambda usage. Or move to a subscription-based plan, which, as we know in the marketplace, really doesn't work. So when you're selling hardware with Alexa functionality, you really have to include the price of the Lambdas over a set number of years in your pricing calculations to take care of that. Amazon charges by the 100 milliseconds for Lambda usage. So the longer your code and communication with your devices take, the more it costs. Remember I said C# is slow? C# is extremely slow when it comes to Lambdas. Remember, you've got to boot up like Windows, and it's got to boot up the weather bug and everything else, and start up everything else, and give a little chime, and then run your Lambda, right? So that's Windows for you. I use Node.js. I'm semi-happy with it. One of the problems I ran into is communication timeout. The Particle I/O Cloud does say, when I get a list of devices, whether the device is online or not. It's not always true. So we had some issues with timeouts. A normal Node.js call will wait 30 seconds. In 30 seconds, the entire Lambda will time out. So we've gone ahead and added a 2-second timeout. If your Lambda times out while doing a device discovery, it will not return any devices. So if your cloud component is responsible for 30 devices and it times out, none of those devices will be returned. Now, Alexa does do some caching, so you may be okay to time out once in a while. The other thing is, if the Lambda times out while communicating with your device, the device may not get the command, or the command may actually get to the device, and the return doesn't get back to Alexa, which would cause just a poor user experience, and it would tell you that something's timed out. This is actually a really common problem with the WeMOS modules. They don't respond in time. What I've used for my implementation for...
Is that timeout configurable in the developer console? Or?
The timeout for the Lambda is configurable up to 2 minutes and 30 seconds.
Okay.
So, but remember, you're paying by the 100 milliseconds. So...
But you don't discover it too often.
Well, yeah, but you're using this, remember, you use the same Lambda for discovery and for communication. So, you're allowing it the time to, what I did, and what I can show you what I did. I've got the code. I did a 2-second timeout on my promise, and so in 2 seconds, if it doesn't return, it cancels the request, goes on to request for the next, because I iterate through device ID. So I go to the, I don't know how you understand the cloud, Particle I/O Cloud better than most here, but there's a API call to get a list of all the devices. It tells you whether the device is online. I go through anything online. I go to that device and I make an API call on that returns a string. And that string has a configuration in it that's very compressed down into a very simple string, just because we don't have a lot of memory on microcontrollers. So, and then that information is sent back, and then that's parsed and turned into JSON. That makes sense. Particle I/O, how many people in here have heard of Arduinos? So an Arduino is a really cool thing. This is kind of the next iteration of it. This is a M3 microcontroller. It's got more power, it's got more memory, it's got more flash capability. It's faster, it's better. One of the things they did was build a device that basically, they took a device and they added a cloud component on top of it. So now in my code, I can say, make this variable cloud accessible. So I can do a get and a put on that variable, and the variable will actually change inside of my microcontroller. I can also call functions, right? So the variables, remember the variables, when I change them, it doesn't call anything. It doesn't make anything happen. It just changes data inside of the microcontroller. The function, I can actually make a function call and actually instantiate some kind of activity in the controller. A couple other things you can do with these. You can publish, you can subscribe and publish to different sources. So very simply, if you want to, I use this to send information out to like Sumo Logic. If I want to push information out to look at, you can also send it to different like cloud components. We can send it out to the IoT hub for Cliff or whatever he wants to do with it. And basically, and the interface is very robust. So if you need to add an API key or different headers, if you need to add an OAuth authentication layer to it, you can do all of that inside of the Particle I/O cloud. And I just say publish to and a name and what I want to publish, and the rest of it's handled by the cloud. There's an online IDE for programming these. It's very simple to operate. I love it because I can go anywhere, code, push code, good to go. My controller can be in California, I can be in Ireland, and I can push code. And that's pretty amazing in and of itself. If anyone's ever fought with an Arduino to try to get the serial port connected to work, you'll love this feature. So this is, we're going to look at kind of how this, what I've written kind of works. Before I do, does anyone have questions about how the Amazon Alexa home automation layers work? Yes?
I'd like to know, where do you store the access token? Like, is it on the chip that you just showed?
So when I go into my Alexa application on my phone or alexa.amazon.com, and I add a skill, it immediately goes to Particle I/O and asks for a username and password. It then takes that username and password, generates an OAuth token, or access token. That access token is passed back to Amazon. Amazon stores that access token as part of their profile in your account for that skill. And so anytime that you call that skill and it goes out and hits the Lambda, takes the access token, passes it back out. And then the OAuth layer at Particle would then take that access token and say, hey, who are you? Okay, you've got an access token, it's valid, I'll let you through. That makes sense?
You said you gave an example for logs, for example. So all these components has to be electrical powered, right? Otherwise, if it is a mechanical component, you cannot open the door, or you cannot close the door.
I'm sorry, say that again.
Say I have a lock.
Yes.
I want to open this door lock.
Yes.
But the door has to be powered by electrical.
Yes,
If it is a mechanical, there is no sense of.
that's correct.
So all the things what you are going to work with it is first of all, it has to be converted to the electrical part of the component.
That's right. So the lock for my front door has 4 AA batteries. And those AA batteries last about a year.
Yeah, still,
But it still has to have a power source. It still has to work. There's other ways of providing power. My cameras out back have a battery in them and they have a solar panel. So they are recharged automatically. You could, inside of a car, you could use motion to generate some kind of electrical field that could recharge something. Same thing with a wristwatch or something. But you're right. I mean, it's got to be electrically controlled in order to be controllable through.
so I have a few more questions if you don't
Yeah,
mind.
absolutely.
What is the objective of this presentation?
What is the what?
What is the overall objective of this presentation? Because I'm new to this industry.
Yeah, so-
I'm trying to understand.
Yes, so Alexa has a number of different
Application.
voice interface capabilities. And this presentation is about the home automation and how that works, so that you understand, if you want to build your own home automation skill, that you understand what's required to do it, and then how that works, and then do a demo of an actual working implementation.
Another thing is, everybody knows you around here, I guess, except me. But I don't
My mom
see-
called them all.
I don't see anywhere your email address or phone number or how.
Yeah, I have cards up here.
Okay.
You're more than welcome to grab one. If you have questions, you're more than welcome to shoot me an email.
Curiosity or whatever,
Yeah.
in case someone wants to reach you.
Right, or you can post on the meetup group, right? Because I'm part of that too, so I get that message too. So yeah. Other questions before we?
So at times when I turn off my Philips lights, right?
Right.
They don't turn on. Like out of 6, maybe 5 turn off, and there's one hanging out there.
Yes.
So on my phone, every night I'll turn it off at a certain time, but then 5 minutes later I turn it off again.
Right.
I wanted to buy a garage, automatic opener that I can control for $30-40. And then when I went to buy it on Amazon, I read that at times it's finicky.
Yes.
It's closing it open, so it frightened me. I didn't buy it. So my question is, with Alexa or even without Alexa, when you do something, is there a way you can check that it was actually done? Like the light part, I'm thinking, can you buy a light sensor and keep it somewhere in the room, so when the light goes off, the sensor will trigger, so it will send you some sort of message and say, yep, the light actually went off. It actually
So
went off.
that's,
How do you do something like that?
yes, so that's something you could build into your cloud. Like, for example, my garage door opener has a sensor that actually gets stuck to the garage door. And it knows whether that sensor is in this position or in this position. This position obviously means that the door is open. This one means the door is closed, right? And that has a small battery in it, and that reports back to my wing. And then I have another device that's attached to the garage door opener that actually controls the garage door opener. It actually has a blinking light and a buzzer to alert you that I'm opening or closing the door, which is, I think, a great safety feature. But you're right, the Wink device is aware of what position that door is in, and it knows and can report to you whether your door is open or closed. So that allows you feedback, but that's done at the cloud level. So Amazon doesn't provide any way of authenticating that anything is done other than the cloud, for whatever component you're using, reporting back. So what's likely happening, and this is very common, because lambdas are billed by the millisecond, by the 100 milliseconds, it wouldn't be outside of the realm of possible that Philips has decided to send a request off to your house and not wait for a response and return back to Amazon that everything's okay in order to save money. So that's not outside the realm of possible. In fact, it sounds like something I might do to save a little money. But if you wanted to add a light sensor, you could do that. You would then have your cloud component to the light sensor and wait for it to respond before it responds back to Amazon.
That's
So
the
that-
extra work, which just get packaged with the system. So
Yeah, and it's not without, you know, it's not without issues.
right.
But this is where, you know, device reliability in the marketplace kind of is a problem. I have Lutron in my house. I have Lutron in my house because Lutron has been in the lighting business for 50 years. They have radio controlled lighting in a commercial sense. They've had it for years. They took that and they put it into homes. My system's rock solid because of the vendor I chose. It's also a little bit more expensive than some of the other options that are out there. So, and when we talk about home automation, a lot of times people are like, hey, it's $14. Cool. Okay, it's $14. But what happens if the company goes out of business? They're no longer paying for their land or their cloud usage. Your device no longer works. What happens if they decide if the device just isn't really written right? You know, obviously you're going to have problems with it. So this is one of the things when you talk about home automation, kind of outside of this, but we talk about home automation, you really do have to be careful about third party or unknown names or, you know, looking outside of that to make sure that you're getting something that actually is going to work and work for a long time. So.
One other quick question.
Absolutely.
Is, I've written a simple app, and I guess you create an intent. So I'll say,
Yes.
hello world, and
Yes.
do something.
Yes.
So if I'm turning on the lights, right, and say turn lights on, turn lights off, it's automatically connecting to sort of a Philips piece. So if I wanted to say turn the lights on, but I only, for example, wanted to do, like you said, turn the lights blue,
Right.
but I don't want it to talk to Philips, I wanted to talk to something else. Where is that? Is that a custom intent, or is that just?
It's not. It's actually, so it's built in. We have a couple different boards around the room. So if we do Alexa, make red room blue.
Sorry, I'm not sure about that.
Alexa, make red room blue.
Sorry, I didn't find red room.
Alexa, turn yellow room blue.
Yellow room isn't responding.
Alexa, turn pink room blue.
Okay.
There it is. Alexa, turn pink room green.
I don't know how to set pink room green to that setting.
Alexa, turn pink room green.
Sorry, I didn't find pink room.
This is obviously the problem with Alexa.
I promise it worked before you guys walked.
Your
It-
accent, man, it's your accent.
I'm not quite sure how to help you with that.
Alexa, turn pink room green.
Okay.
Alexa, turn green room red.
Okay.
Success.
Okay, so what's happening is that's part of the device discovery. So when I do the device discovery, I go out to the particle cloud. I get a copy of, I go through and I say, what particle photons or what particle devices are attached to the cloud, right? Because all of these little controllers are attached to the same account. And then it goes through and it queries each one of them. And it says, what devices do you have? And what capabilities do you have, right? And it returns back a string and a bit-based, like a number that each bit means a different capability. and then returns that back. And it does that for every device in the room, all 5 of them. And so when you call Alexa, all it knows is to send the information to the particle skill. And then the particle skill just gets a copy of whatever you sent for the discovery. In this case, it uses a key-value pair that's returned during the discovery to take and be able to go, okay, one key is the device ID, which tells us which device in the room it is. And then each of these devices actually has a couple of devices attached, like I can do Alexa, chair fan off.
Okay.
Alexa, chair light off.
Okay.
Alexa, chair fan on.
Okay.
So one physical device, 2 virtual devices, right? So we return the device ID, which is a GUID, and then we return the index of the device, 1 or 0 or 1, right? And that's how it handles it.
So in this case, chair fan is sort of the name of the device.
Yeah, so
Chair light.
chair fan, chair light, right? So this is the actual code that runs on the Photon, and this, what my skill does, and the library that goes with it, is it abstracts away everything that we've talked about here today, and it makes it very simple to implement. So as you can see here, when we look at the code, and it won't take us long to go through it, this is my library. I instantiate a copy of the library itself. This is my setup. I'm making a pin and output. I'm adding an echo device with an on-off capability. I'm calling it Photon Light. And when Alexa calls Photon Light, I automatically call the function on-off. And you can see here my function on-off. Remember I said that the devices, we have virtual devices, 0, 1, whatever. That device ID is given back to the function. A Boolean of on-off tells you whether I told you to turn it on or off. And then the raw parameters, which is just a raw list of what was actually sent, in case you want to parse it differently yourself. And then as you can see, I'm going to do a digital write to D7, which is pin D7. Based on off, it's either going to be high or low. That's it. The other devices in the room are a little bit more complicated. So
you have a Wink hub for all the devices?
this is my wife saying, "Did you lock our door?" Should probably tell her yes.
Just say no.
Did you turn off a television?
It was Big Brother.
Did I turn off the television? No, I did not.
You know what to.
No, but this is funny because my wife was in Virginia one weekend and I was at home, and she's showing her mom that she can turn on and off stuff using the Lutron app on her phone, and I'm sitting here going, "Why is the lights going on and off? Right? What's going on here?" And our fireplace is actually controlled by Alexa too. So as soon as the fireplace turned on, I knew what was going on. So it was kind of funny. So this is the simple app. This is the Particle I/O. This is the IDE. And for anyone who gets to play in like Visual Studio or whatever, this is like
Can you zoom your text?
Huh?
Can you zoom your text with the editor?
I think Control Plus.
Sorry.
You're fine. Is that better?
Yeah, absolutely.
It's very simple, right? This is the same code, but if we look at what's actually on, come on. So this is actually what's on the controllers in the room. It's from the Girls Coding Camp demo we did. And you can see we've added a couple things. We've added fast LED, which controls the LEDs. We've added an LCD or an OLED. But you can see then when I start looking at the device creation, I'm doing the same thing. So I start with a color, and each one's given a different color. So if I do Alexa, green room on.
Okay.
Alexa, set green room purple.
Okay.
So those allow me, but if I also do Alexa, set green room slide yellow. Alexa, set green room middle to yellow.
Okay.
Obviously, it's not wired up to run that. But you can see that we've added additional devices, right? And so we can keep adding the same device. We can add color, percent, color and percent. We can start adding lock. We can do so in this one, we're doing temperature control on the blanket, right? So we can do temperature control. We can do lock. Obviously, color, percent. And all of these are abstracted away, so you just call a function in your code, and there you go. It's pretty simple. Any questions to this point? Yes?
Can you schedule the functions like turn on the green room to red after 5 minutes?
The what?
Schedule, can you schedule?
Can I schedule them? You cannot schedule them in Alexa. However, some cloud applications will allow you to do it. My Lutron system will actually allow me to select a number of lights and tell them to turn on and off at random during a set amount of time for a set amount of days when I'm on vacation. Or I can tell it to turn on and off my front garage lights. I can turn them on at dusk and turn them off at dawn. So that can be a function of the cloud, but it's not a function of Alexa itself. Does that make sense? Okay.
That's an interesting, but I know that Alexa, I didn't realize it's, if I play music, right, I can say Alexa, turn off music after 15 minutes and it automatically turn it off.
Yes.
So that's a different sort of interface than trying to say turn off light after 10 minutes.
I've never known it to work that way.
The other thing-
Alexa, turn off fan.
A few things share that name.
Alexa,
Which one did?
turn off chair fan in 1 minute.
Sorry, I didn't find turn off chair fan in 1 minute.
I have a guess what you're talking about is native Alexa
Right.
functionality.
Yeah.
So Amazon built that into the music player.
Right.
Right.
But I
It's
don't.
outside of your intent, so.
Yeah, exactly. I think it's part of the music system and not part of the home automation system. I've
So
never.
people can go to sleep. Like at night, like I play music.
Yeah.
Like I go to
You sleep?
Sometimes.
Sorry.
Leaving the house.
So yeah, I mean, it's. I've not known it to be able to do that, and so it must just be a system part of the fan, part of the music system.
Yeah, so you could write an Alexa skill kit, and then pass into your particle function
Yes.
the data to tell it
Yes.
to turn off at a certain time or something like that. And
Yes.
Your photon could do that.
Yes. And more to that point, you could build a home automation skill, right? And you could build a custom skill. And you could have them talk to the same Lambda, right? And just extend the feature set of the Lambda. Or have a second Lambda that talks to the Particle IO cloud, right? But you'd have to have something that handles timing. So something in your cloud would have to be able to have a scheduler that would schedule out turning off.
Hey, Jaron.
Yes.
When I'm trying to understand what code does,
Yes.
particularly on the Photon and Arduino, I'll use the serial println function so I can see kind of where my code is at and what it's doing.
Yes.
With the things that you're covering tonight, with Alexa, Lambda, Particle IO Cloud, is there a way to do that same sort of thing where you get like logging information so it can tell you kind of what it did or what it's trying to do?
Yes. Now, one of the cool things about the particle is because it's programmed over the internet, you can actually leave it plugged in and as a serial device. But every time you program it and reset it, you'll have to, I use putty, so I have to restart my putty session, right? Because the serial port drops and comes back. Better than that though, is if you look at the console. So the console will tell you what's going on with your devices. So if I take one of my devices and I reset it, in theory, I should see it come up here.
You got that from the ID?
Yes. Now the other thing is you can take, and my favorite thing to do is to do a publish. So I don't know if the girls coding does publish anymore.
What about the JSON file that's being passed as communication between Lambda and all that? Does that show up in there too?
That will show up in, so if I look at my Lambda, if I look at the Lambdas itself, there's CloudWatch, and CloudWatch, and this is actually a really good thing to show. It's the Particle IO bridge, that's the one we're running. And if I look at monitoring, logs in CloudWatch. If I'm going too fast, somebody stop me. This is really simple stuff. You can see the actual streams. Now, I use log functions, right? So this shows you exactly what's going back and forth. And all you do in your Lambda is you just use a console.log in Node.js. And then you can so like I have a generic log statement that abstracts away console.log in case I want to do something else with it. But there's my log, my error, no supported namespace, event, header namespace. One of the reasons I like Node.js is because it supports, yeah, you can see my device came online, went offline. Now, when I use a publish function, you'll actually see what's being published. And I don't. Yeah, it's on here. So if I do. Alexa, pink room off.
Sorry, I didn't find the...
Alexa, turn pink room off.
Okay.
Now, you can see here where it says sumo logic. Call echo function v2, 0:1:0. Okay? This is what's happening during a publish statement, and you can see the actual data that's being transferred. The one thing I will warn you about is that there are some rate limiting. There is some rate limiting that is built into the Particle IO cloud. So if you start running publish statements, 8 or 10 or 20 in a couple milliseconds, they will stop working. It's just kind of a rate limiting built in. There's documentation that'll tell you what the rate limiting is. You can look at it. I tend to use a debug state. I tend to use a constant to turn my debugging on and off, and turn different parts of the debugging on and off. So, which is really good.
One other kind of clever way to do it is I do a publish, and then I have if this then that sends the trigger to Evernote, and so I just look on my phone what the logs are.
Yeah, no, that's a really good one too. So, and if you're working with things that aren't so log heavy, you could send it to your phone. You could do a lot of things with it. So, I mean, but this is the cool thing about, we have integrations, and so I could do a new integration, and I can do Google Maps, Azure IoT Hub, Google Cloud Platform, or webhooks, but I've rarely seen a webhook implementation that is so advanced. You can see I can add query parameters. I have basic authentication, HTTP headers, responses, default data, obviously the URL, the request type. So, I mean, this is a very, you can choose what device. It's a really powerful interface. So you send the data almost anywhere, right? And if you have to send it beyond what this is capable of and do anything special more than that, you always have like an Nginx proxy or something like that with an API key that would reproxy it through. Especially if you needed, to secure things down, so that this might come from any IP. You got like AWS stuff that you're trying to secure access to. A simple Nginx might be the best way to kind of proxy that. What other questions?
Can I add multiple libraries to particle? Firmwares to particle?
So when I look at, this is the girls coding demo, which is running on the 4 boards in the room. And you can see I've got the Echo Photon bridge. I've got fast LED, which is for those who don't know, the fast LED, this NeoPixel and other implementations, it's bloody amazing, right? So if you do anything with NeoPixels, you're more than likely using fast LED. And then I'm using the particle one. And then if you see later on down, I'm actually using the ADA Fruit implementation for the OLED. You can see I've got their graphics library and their SSD 1306, which is the little 128 by 64 OLED I2C chip, which is one of my favorites. Very simple, 2 pins, it's up and running, no big deal.
Can you make that code bigger again, please?
So, and this code actually started as an OLED. sample, which is why it's so LED heavy. But and in order to add a library, if I were to add a library in the IDE, I simply go in here, and let's say I wanted to add one for, an 1820. A DS18B20, which is a one-wire, temperature controller. All I got to do is select it, include in project, choose my product, choose my project. I don't tend to have a lot of free time, and I will tell you that one of the reasons I love the particle is because the development is so very quick. I can pump out devices and products so fast. It kind of blows your mind.
I hacked my daughter's e-war while we were eating dinner one night and did
Nice.
an IFTTT skill, and I think it took 20 minutes from the
Yeah.
time I cracked the seal on the particle photon until I had IFTTT triggering the e-war based on Google skills.
And the devices themselves, they run about $19 MSRP. They are little tiny boxes. And they have a USB port on them, so you can power it over USB if you want. It's normally the way I power my projects. And there's 2 buttons on them. They're Wi-Fi enabled. There's a smartphone app. It is not like most other smartphone apps that kind of work. I rarely have a problem with it. You know what I'm talking about, right? I mean, it just works, right? So you go in and you say, it's got a little blinky light on there, and it blinks a certain color. And then you're getting bored, aren't you? You're ready to go, aren't you? It's okay. It really is. There's a little blinky light on here, tells you what mode it's in, and then you can assign it to a Wi-Fi, right? Everything in here is assigned to my, my Verizon wireless, what do they call it? MiFi. Hotspot. And my house has the same wireless hotspot.
What is that device? What's the times? I think I'm zoned out on that part.
So this is the chip that we're actually using to do, that I'm using to do my home automation interfacing.
Okay, so it's a general purpose chip that can.
Yeah, it's basically an Arduino. So it's basically an Arduino. It's faster, it's better, it's more memory, more flash capability. It's got a lot of people.
Output pins that you hook something up to.
Yeah. So if you look at one of the boards, you can see that we've taken a couple pins and we run it to the LED. We take one more pin and we run it to the. We take a couple of the pins and run it to the display, and then take one more pin and run it to the LEDs.
Okay, so that's all it is. It's just the tiniest little device that you can has wireless networking. You power it up and it has pins that you drive.
Yeah. Well, it's more than that. I mean, it's actually a microcontroller. So I can.
Okay.
It's not only just, hey, turn this pin on, turn this pin off. I can actually implement code like.
You can have onboard code.
Yeah, I can have onboard code, right? So just like an Arduino.
Like an Arduino.
Right. And having a web interface allows me to program it over the internet, so I don't have to sit there and plug a cable in and make sure it's, it's on the right
So it's
serial
got
port.
onboard memory and all that good stuff.
Huh?
Onboard memory and everything.
Yeah. Yeah. In fact, it's got onboard EEPROM that you can use to save like variables and stuff. I didn't have time, but I wanted to use that to save the name of all the devices in the room. So if I wanted to push code to them, I could push code to them. From a commercial standpoint, you can actually take like 100 of these devices, put it into a product group, take that product group and push the same firmware to the entire product group, or make changes to the entire product group. So it's very much an enterprise level capable device. So I'll pass this around.
We are coming to 5 minutes, but if everybody's okay with extending, we'll go ahead.
You have one more question? Oh, you have one.
Several questions.
Yeah, I've seen these.
Any other questions?
What devices, say you have the Lutron, I know they have the G switches, but what types of devices do you have on for home automation?
For my home automation, I have a couple of WeMOSes that are going to get replaced, just not reliable. I'm going to replace them with actually one of my chips running LEDs underneath we have a light strip underneath our platform bed, which is nice at night. You get a little bit of light, but not a lot of light, right? So we're going to make that colored, and I'm going to add a little bit of, paparazzi mode, police mode, I think will be funny. My wife probably won't think so, but I took a Lutron power switch, on-off switch, hooked it up to a relay. My fireplace is low voltage controlled, so the 110 volt on off turns on and off the 110 volt relay. The relay itself controls the low voltage lines, right? And I did that prior to doing any of this. It's a rather expensive solution, but I wanted a voice activated fireplace, so I spent the money. We have the lock up front is Schlag, so we have a Schlag lock, a Go Control unit in the garage for the garage door opener, and that actually hooks to the two lines that run to the push button. So it is a very standard and easy to install, works on almost any garage door opener type of solution. And I like the safety features. It blinks a couple times, it beeps a couple times, and then it activates the door, closing or opening, right? So, It's called Go Control. It's the same thing that Lowe's sells it as theirs, under their brand. I have a Wink hub that controls that and the light and a couple automated, a couple power strips. I have internet-enabled power strips to run my 3D printer, so I can turn them off if I have to. My wife calls and says, something's wrong. And I'm like, all right, I'll turn them all off. Done, right? And I go home and she's happy. There's value in that. I will tell you this, and this is Dan's line. If you're going to do home automation, right, make darn sure it works. Because the first time it doesn't work, your wife's going to ask you how much it costs and how much you wasted, right? So I like really reliable solutions. I'm a reliability engineer, so obviously it's really important to me. I do recommend Lutron for lighting. I do not recommend lights that screw into the socket, because then the switch always has to be on. And if the switch gets turned off, obviously it doesn't work anymore, right? My Lutron devices, if I lose the internet, the voice automation doesn't work. So my Comporium internet, I have 1 gig fiber internet. If you ever get a chance, it's awesome. Thank you. But I also have it backed up by Verizon using a hotspot. So my internet will fail over, right? So if there's a problem in the house, it will fail over. Not only for that, but we've got some other things in the house that I have to have internet for all the time. But if there's no internet, I can still walk over to the wall and I can push the button, right? Lutron's a very simple system. It's just a couple of switches. There's not a lot to it. There's not a lot of options. It's very stable. What else do we have? That's pretty much it for home automation. And obviously we have Echoes throughout the house. And we call them, they can be called Echo or Alexa or whatever. The one in my office, it's Echo, so that when my wife turns on something, it doesn't, or when I'm playing, I don't mess around. So, yes?
Did you automate your 3D printers to be
What?
operated by Echo?
He will now.
My 3D, my 3D printers can be turned off and on by Echo.
They do.
Right, they could be. They don't. I don't have that. I don't have that turned on because I don't trust that I won't say something to turn them off when they're in the middle of printing. So, yeah.
Let me ask you a question.
Yeah. No.
What it is going to save us, time or money or laziness or advanced or?
So there's a lot of reasons. Charlotte IoT is running a project right now for Civic Hackathon. And one of the things we're doing is we are taking people that are disabled and we're giving them the option to be able to turn on. We delivered a couple weeks ago to a gentleman the ability to turn on and off a light, a fan in his room, right, and control his TV. Turn his TV on or off, volume control, channel on or off, right? And Steve is a, Sean is a quadriplegic?
Yes.
Paraplegic, quadriplegic.
He's paraplegic.
Paraplegic.
Next squad.
Right, so he has very limited mobility, but he definitely cannot run a remote control. I can tell you for me, for my house, a couple things. First off, when I'm cooking, the ability for me to be able to ask Alexa questions is kind of imperative. My wife doesn't do conversion very well, so she can say, you know, Alexa, how many cups is 17 tablespoons?
17 tablespoons is 1.06 cups.
Right, or she can do it the other way, right? I've done it for math, you know. Alexa, 317 times 42.4.
317 multiplied by 42.4 is 13,440.8.
Okay, I can't do that in my head. Paper, if I had it, I could do it. Setting timers, imperative for me for cooking, because I will go and start something, go in my office, and forget about it. I burned way too much stuff. I set a timer. It allows me to go, I'm gonna go in my office, I'm gonna check something. I get distracted, 20 minutes later, the house is on fire. Not a good thing. This way, I set a timer for 5 minutes, I go in my office, it starts yelling at me in 5 minutes, and I go back to it. Yeah, it does. Being able to turn on and off the lights, being able to get into bed and turn off the lights with a voice command is a very, very nice thing. I've had that for years. Used to have an IR controlled lights in our bedroom. And that's just, for us, very convenient. So there is a lot of convenience. It does save time. You know, is it being lazy? Probably.
Efficient.
But if you've ever seen me running around with my head cut off, I've got a lot better things to do with my time than run over and hit a light switch. If I can use Alexa and a voice command while I'm running through the house trying to get 30 other things done, I think it allows me to be more productive otherwise.
Yeah, but you could use the photon to be an input and have a go to sleep button or a holy crap, you know, set off the alarm button as an input to a photon to trigger Alexa skills, right?
Yes.
So for me, I have one that is good night, and it shuts everything down.
Yes.
Turns on the outside, and then I'm rigging up one that's my oh crap button, and I'm fast LED. They have neopixels, and we'll wrap my whole house with them because they have a new outdoor one that looks like Christmas lights, and then you can do what we're doing with those lights on the outside of your entire house, for like $150, and I'll have to take Christmas lights down every January or April whenever I get to.
I hear you.
And you can make them orange for Halloween. Orange and purple, exactly.
That's right. That's right.
A comment on the work that Jeremy's done with Charlotte IoT. It's literally been life-changing. I mean, when we delivered this for Sean and he saw the things that he could do from voice, where before he'd rely on family to do that stuff, it was life-changing. And Jeremy's just done an incredible job with this, and the code is just incredible what you've done. The particle echo bridge, it's just really incredible.
And just, I mean, just as a aside, November 4th, Charlotte IoT is going to be doing their next hackathon. It's going to be at Lending Tree. I'll post a link to it on the meetup if you're okay with that, Aru.
Yes, definitely.
And
Any questions that you might have?
yeah,
Please
and I'm pretty responsive, so if you have questions later on, let me know. This is kind of one of the passions. I just got tagged at work to do Alexa stuff because, you know, they kind of know me as the Alexa guy, which is kind of cool, you know, to be able to do passionate things at work. So, you know, that's really kind of been a good day for me. Yeah, I mean, you'll find when it comes to the Alexa stuff, when you get down to it, there's not a lot there. But there's a lot of busy work. There's a lot of little things you'll learn. There's a lot of things you'll learn, like how to name devices, how not to name devices, especially Vijay here, who sometimes he might not want to name it one word, but name it another word, just because of his accent, right? And that's okay, right? The other thing to know is that Alexa does operate not only in English, they're starting to do Hindi, which if anyone in here knows, there's no Hindi language, so it's kind of, I thought, funny, honestly.
I get what you're trying to say with your accent.
So, I mean, but it does operate in different languages. The voice control systems do have, the custom skills have to support it, but the home automation already does natively. So I'm working right now with a guy in Germany. There's a guy who's taken my stuff and uses it to start his BMW. BMW on in the morning, BMW off, right? I mean, why not? He's got access to the API, and you know they've hacked it, and so he can do that. You know, so there's a lot of things you can do that are outside of, you know, just the realm of standard stuff. We're getting ready to do, so this setup up here is a power pack, a photon, a light, and a fan, and an echo, all battery powered. We're looking at how to put that on a wheelchair, right? I mean, imagine the power of that. So there's a lot of things outside of just home automation that really makes it quite fun to think about how you can leverage this. I want to lock my wife's car doors with this at night, honestly, and I think I can. So.
I'll show you the last question.
Yes.
I had a robot which pulls my house. So vacuuming or whatever you say. Can I operate with Alexa and robot?
You could, but typically a robot, you want to have a little bit more, you want to have a little bit more granular control over it, so you'd want to be able to start and stop it. Robot, if it's like a vacuuming robot, then yeah, you could tell it, if it had an API and it had a cloud component, you could tell it, hey, you know, robot, Alexa, turn Roomba on, right?
Starting
Alexa.
discovery. This will take up to 20 seconds.
Okay.
If you haven't already, enable the smartphone skill
But,
device from the Alexa app.
yeah, but this is the thing. The device itself has to have a cloud component that supports it.
The device has to be connected to something API has to be adapted.
Right, so either you've got to write it or the manufacturer's got to write it. So, and something like this could be wedged inside of the device. I've got a fan, an old fan, that I've put one of these in that I can control now. So it's just a little fan, but now it's, you know, internet enabled. And so, you know, there's a lot of different things you can do with it. The reason I built all of this was so that I could do not only the hackathon stuff, you know, the stuff for the disabled people, get this out there for people, but also because when I want to build something, all I've got to do is throw together 8 lines of code, 10 lines of code, 20 lines of code, right? Say, Alexa, discover devices, and it's online. Wow, I'm done, right? So I like that simplicity for myself.
Where can we see the code?
So the code is, I'll post the GitHub to the code and to the examples. The Node.js is not published yet. If you want a copy of it, let me know.
Ooh, I do.
Jeremy, if you're okay, if you update the slides, you can put it on the meetup too.
Yes.
The discussion group. So that
Yes.
we can connect it.
And it walks through, the GitHub actually walks through how to set everything up, what you're going to need, example code, a demo video of it. I will warn you that this is all going to change because Amazon says I can't call it Echo Photon Bridge. So the name's going to change. This GitHub repo will end up being a README redirecting you to the new one. So the link will still work. We'll make sure of that. So I think probably done. For those who brought kids, I brought little toys. If you guys want some, I've got some cool earrings, got some cool necklaces, little doggies. You're more than welcome to help yourself. You guys have been great. You too.
Kids that are up to 40 years of age. Anybody?
No.
That's right.
50, make it a little higher.
Yeah, so if anyone wants to take anything home to your kids or to your wife to tell her how much you love her, or your kids, just because it'll make your life easier, by all means.
These are 3D printed?
Yes, they're all 3D printed. Anything on the table is up for grabs. Come up and help yourself. My card's up here if you got any questions. I'll post my information online. There's some pen holders up here, some Tiki pen holders. There's a couple of, these are really cool. I brought these just so people can understand how accurate we can print. These are actually screw top containers. Pretty cool. Huh?
Flashlight.
Oh,
Flashlight?
I don't have any flashlights.
Flashlights.
I had flashlights. I don't anymore.
That's the right accent with a different company.
There's even a 3D printed bowl. There's a little blemish on it though, but still it's usable. So by all means, help yourself. I have a lot of stuff that I print just to give out, so more welcome to anything. If anyone's got any questions, post on the meetup group. I'll post some contact information to GitHub up there. And I really appreciate you guys coming and appreciate you guys making me feel so welcome, especially for my first meetup presentation. Thank you.
Great job.